recording. Okay. So let's see. Let me start over. Sorry about that, folks. 2.2 we're going to do today. If you want your answers to be right on the practice test, you have to put braces on them. I don't care if you get them wrong or right on the practice test, so don't worry about that. Don't worry about it for the real test because you will have multiple choice on the real test. There is a scholarship opportunity out there on the slide for STEM majors who have 30 hours or more by the end of this semester at TCC, and our minority students. So go check that out. It's got a date of about a week from now when you have to apply for it. Okay, let's finish up this first problem. We're looking for where f of x is less than or equal to 0. Remember, f of x means y. So we are trying to describe the x pieces where y is less than or equal to 0. Here's the y-axis. So where y's are less than or equal to 0 is down here on the bottom half. And let's look at what those x's are. We're trying to find those x's. They go from here on the x-axis, that's a -2.5, until 1, 2, 3, 4, 5.5, something like that. 5.5. It includes both of those. So that would be the answer there. From -2.5 to 5.5, all of that is where the y numbers are less than or equal to 0. They're giving you the y, zeros, less than or equal to 0. They're asking you to come up with the x's. Okay, let's move to this one. The second drawing, we're looking for where we're increasing. What intervals are we increasing on? And there is nowhere. Remember, you're traveling left to right on this roller coaster. You're going down and then you're staying flat. So there is no increase. B, we're looking for where interval is decreasing. Here's where your roller coaster ride is decreasing. Remember, you have to go left to right. So let's pick this up where it starts, way down here on -infinity. And then it stops decreasing there at -3, -1, -2, -3 on the x-axis. It stops decreasing. You level out there. So -3. Put a parenthesis on there because it doesn't include -3. Once you get to -3, you're no longer decreasing. You're starting this constant piece. So -3 is not decreasing. And then we're looking for where we are constant. We are constant along this piece right here. Again, we're going to name it going left to right. So it starts at -3 and it goes on out to infinity. This roller coaster ride will never end. You're just going on a flat line for the rest of your life. -3 does not get included because you're not constant at -3. You're not decreasing. You're not constant. It's just part of, the transition. Okay, what else do I want to do here? Okay, I was going to look at relative minimum here, but it's weird what happens because of this, so we're good with these three. We're content with just those three. Okay, let's look at this messy thing. Let's first look at increasing. Where is our interval increasing? These arrows are doing that thing. This is going out this way and down this way. So where are we increasing? We're increasing on our roller coaster ride there. This piece right here is an increase. This piece right here is an increase also. Remember, we travel left to right on our roller coaster. So we're picking this one up at -infinity. And then we stop there at, what is that? -1, -2, -3, -4. This stops increasing at -4. Don't include it. None of these intervals will ever include the numbers that we're talking about. Here's another place where, we're going to go down here. We'll catch that later. But here's where we're going to start back up on our roller coaster. So from here to here, we are increasing. You're looking for the x numbers for that. So that is -2, -1, -2. Your increasing piece on your roller coaster begins at -2. And it ends at +1. And again, both parentheses there because we're not including -2. We're not increasing at -2. That's just where the transition begins. We're not increasing at 1. We don't continue to go past 1. we're turning around. So -2 and +1 are just transition points. Don't include them. Those are the total increases. Let's look at decreasing. Decreasing. Our roller coaster ride goes down here from this place at the top to this place at the bottom. That's a decrease. And then this is a decrease also. So we're going to have two decreases here. Let's look at this one. Where on the X does this begin? -1, -2, -3, -4. So it begins at -4. And your decrease ends right here at -2. Then there's this other decreasing segment here. It begins right there. What is the X coordinate at that place? That's a 1. So it begins at 1 and it ends at +infinity, way down there. And again, always, these intervals will always have only parentheses. Oops, C. C, we're looking for the constant. Where do we have, where's our roller coaster ride just going along flat? And it doesn't here, so there is no constant piece there. Let's look at relative maxima. It's one word, although it's got a lot of separation going on there. Relative maxima. That means compared to the graph around it, compared to the function around it, where is it as its highest point? So we have two maximum places. That plural is maxima. One maximum, two maxima. Don't worry about the vocab, but just be able to recognize it. So this is a maximum right here. That's at -4. This is a maximum right here. That's at 1. So we have two relative maxima. Relative minima with an A there instead of an UM. It's the plural. -infinity and +infinity are not relative minima. There is nothing around them that shows that that's the lowest because it never goes higher from there. So we're only looking for the places that are within our viewpoint. And we're looking at good, -2, Charles, good. This is the only relative minima that we've got, the only relative minimum that we've got at -2 on the x-axis. All right, let's look at where f of x is less than or equal to 0. So just like the first one that I started with today, we're looking for the x values where y is less than or equal to 0. This says y is less than or equal to 0. So you're looking for stuff that's down here, stuff that's below the x-axis. That's where the y values are less than or equal to 0. We're going to give them the x values for that. So the x values that have a y value that's less than or equal to 0 is this piece, this little dip, and then this one. So we have 3 different pieces. So this piece that hangs out below the x-axis where the y numbers are less than 0, the negative y's, goes from -infinity to right there, 1, 2, 3, 4, -5 we'll call it. So -infinity to -5, and we include that -5. This needs a bracket because this is not an interval where we're talking about increasing or decreasing. This hits there right at -5. The next place where we're below the x-axis is right in here. That's -3 to -1. And then finally, 1, 2, I'll just call it 3 on out to infinity. Infinities always have parentheses because we can't include infinity. It keeps running away from us. It's like that grocery store receipt in the middle of the parking lot that you keep chasing. As soon as you get to further on, it keeps moving. So infinity keeps moving. So we can never include infinity, but all these other numbers will be included. In a classroom setting, I know if my stupid little jokes have worked or not. It's harder to tell. Thank you, Chloe. Sometimes I think I'm just amusing myself. All right, let's move to the next page, which starts with number 1. Here's some cool stuff that we've done a little bit of already. You'll recognize some of what we've done. Determine whether the graph of the equation is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. Well, that's 4 different choices. We've only got 2 graphs to look at. We're only looking at the 2 that matter. So x-axis, y-axis, origin, or none of these don't really matter to us. Just 2 of them do. So we'll see which 2 do. Okay, this one right here, let me tell you, is symmetric to the y-axis. And let me tell you why that is. Here is the y-axis. Can you tell that this is the same as that, except that the y-axis is acting as a mirror for it? That's why we say it's symmetric to the y-axis. That means that, like you are, you've got a y-axis running through you, and you're symmetrical for the most part. I mean, I know you got that one weird eye going on, or that one weird ear, or that one side of your lip looks a little different from the other side, but basically we have a y-axis symmetry. We have an up and down line where our left side matches our right side. That's what's happening with this graph. It's called even. We're going to call it even symmetry. We'll talk about that down here. See, it says determine if it's even, odd, or neither. So we're going to duplicate that work down here. What you know about this is that for every xy point, you have also got a negative x, positive y point. Let me show you with 2 points here. Let's take this little thing at the top of the hump there. That point is about 1, 2, 1, 2. So that point is about 2, 2. What it says down here is that if it's symmetric to the y-axis, then we would expect the x with a negative sign in front of it to also be on our graph. If 2, 2 is on our graph, negative 2, 2 would also be on our graph. Well, where is negative 2, 2? Negative 2, right there. Just as promised, negative 2, 2 is also there. Let's look at another point. Let's look at this point right here. That point looks like 1, 2, 3, 1, 2, 3. So that point is 3, negative 3. If 3, negative 3 is on a graph that is symmetric to the y-axis and is called even, then we would expect the x-coordinate to be its opposite. The y will stay the same. We're not changing the y, we're just changing the x with this even symmetry. So if 3, negative 3 is on our graph, we would expect negative 3, negative 3 to be on our graph. Negative 1, 2, 3, negative 1, 2, 3, and sure enough, there's negative 3, negative 3. So what you need to take from this is the ability to look at this and see that the y-axis is the mirror for this figure. And we're going to call that an even function. The numbering, we're not going to do so much, but it's just proof of it. Okay, this particular guy here is symmetric to the origin. It has origin symmetry, and we call that odd. And what we know about it is that if we take any xy point, we also know that we're going to be able to find a negative of both of those. So what this means is that the origin is the belly button for this, symmetric to the origin, origin symmetry. Being symmetric to the origin means that that's the belly button right there. And if you were to spin this half of the graph, the right-hand half, spin it 180 degrees on that, you would end up with the same thing. So that this point down here, if we were to take this half and spin it 180 degrees, that point at the South Pole becomes that point at the North Pole. This place here, spin it, becomes that place here. Let's look at a point on that and see what happens with changing both of them. Let me just grab this lowest point here. That is like 1, 2, 1, 2, 3, 4. I know it's not exact, but I don't want to be picky about the halves. So it's at about 2, negative 4. What symmetric to the origin says is that we'll change both of these, and that point will also be on our graph. So we're going to change the x to his opposite. We're going to change the y to his opposite. That'll make him a positive instead of a negative. So -2, +4 takes us right up to there. And sure enough, those are both on there. The XY version and the negative of both. And that's called odd symmetry. Okay, so didn't seem like we were too worried about y-axis symmetry. And if it's not one of those, it'll be none of these. So we're only worried, oh, sorry about that. We're only worried about x-axis, sorry, I goofed that. We are worried about y-axis symmetry. This is y-axis symmetry, like you, with a vertical line describing the symmetry. We are not going to worry about x-axis symmetry. We're not going to look at anything that has x-axis symmetry. We are looking at origin symmetry. We'll call that odd. And then something that is not one of those will be none of these. And we're going to have a ton of none of these because some of the stuff we look at is just a mess. Okay, this is visual to look at y-axis and origin symmetry. Let's look at down here. So remember, even is y-axis symmetry. Odd is origin symmetry. And anything else is neither. So let's look at how we're going to determine it here. I'm going to show you the way that you do it if you're thinking mathy, and then I'm going to show you the shortcut. So the mathy way is to test this concept. What happens if I put in a -x? Do I get a y back out? So what we're going to do is we're going to put in -x in place of x. We've done this. We've done this several times. Let's go over here and put in a -x to the fourth, -x squared plus 2, negative to the fourth power makes it a positive, so we get x to the fourth. Then we've got a minus sign. Then we've got -x squared, that gives us an x squared, and a plus 2. Look at what we ended up with. We ended up with our original y, x to the fourth minus x squared plus 2. We looked at that a couple of times on Monday in preparation for this. So what happens is when we put in a -x, we get the original y. Remember, that means y equals. We put in a -x, there's no change. That means that this has y-axis symmetry, which they did not ask us about, but they did ask us if it's even or odd, and it is even. So that's an even function. Now, let me show you the really easy way to determine if it's an even has a 0, x to the 0 that I've described a couple of times, getting us ready for today. This missing variable here could be x to the 0 without changing it, because remember, x to the 0 equals 1. You two what, Felicia? Oh, I'm frozen. Wow. Okay, good. I don't know what happened, and I didn't get notification of it. Sorry. Okay. Oh, bummer. Okay, so what was the last thing that you heard me talking about that I was writing about? Y-axis symmetry, even. Okay, right here, this even? Okay, cool. So you guys were right on top of it when, okay, great. Chloe, thank you for jumping in on that. So I don't think we lost a lot. Okay, so let's see what we can do here. Let's repair this. So this is an even function. The easier way of telling, and oh, I think that's what you missed, was the easy peasy way of telling. Look at the exponents. 4 is an even number. 2 is an even number. And then this guy right here, he doesn't have an x on him, but if we wanted to put an x on him, we would say x to the 0 power, because x to the 0 power is a 1 and doesn't change the constant. So look at those exponents. They're all even numbers, 4, 2, and 0. So this is an even function. You don't need to mess with this crap. If it's got all even exponents, you know you've got an even function, and it will be symmetric about the y-axis. It'll have the same left-hand side as right-hand side. So you don't need to do this math unless you're just dying to do this math. Okay, let's move on. Let's look at this guy. In order to determine if it's even, odd, or neither, what we do both times is and I'm going to show you again the difficult way to do it, the easy way to do it. So let's look at the difficult way to do it next. The more difficult way to do is to put a negative x in and see what you get back. If you get the same old thing, then it is even symmetry. If you get a negative version, then it is odd symmetry. And if you get some other hodgepodge, it's none of these, it's neither. So let's put in a negative x. Remember, this is the more difficult way. Put in a negative x to the third power minus negative x to the first power plus 3. See what we get. Negative to the third power is a negative, x to the third, that's cool. Negative times a negative gives us a plus x plus 3. Okay, let's see what happened between this and what we started with. Started with x to the third. Ooh, we've got the opposite of that. Started with a negative x. Ooh, we've got the opposite of that. I'm thinking we might have odd symmetry here. Positive 3, oh, clunk. That's not the opposite. So we didn't get the exact same thing. If we had gotten the exact same thing as our original equation, it would be an even function like we had on the first one. If we got exactly opposites, this is a positive, this is a negative, this is a negative, this is a positive, oh, clunk, this is the same, it would be a neither. So sorry, if we'd gotten the opposite, it would be an odd function. But we got nothing. We got a dud here. We did not get the same thing as we started with. We did not get opposite signs on everything. So this is a neither. And we would expect that. Let me show you how to do it the easy way. The easy way, if it's even, if this is an even function, these will be even exponents. Nope, that's not the case. If this is an odd function, these will be odd exponents. Let's look at it. 3 is an odd number. Cool. 1 is an odd number. Cool. 3, that guy does not have an exponent on him, so let's put one on him. 0. Oh. That's not an odd number, that's an even number. So this does not have odd functionality because all of the exponents are not odd. So this is a neither. Let's look at one that does have odd functionality. Look at that exponent, that's a 3. Look at that exponent, that's a 1. Those are both odd numbers, so this is an odd function, guaranteed. Let me show it to you mathematically. Put in a negative x for each of the x's. Negative x to the third power minus negative x. Negative to the third power, x to the third. Negative times negative is a positive. Now let's see what we've got. Let's compare this to the original. X cubed to its opposite. Minus x to its opposite. Everything is odd there. Everything changed to its opposite. And if it changes from positive x, positive y, to negative x, negative y, or an x and a y and their opposites, that means it has odd symmetry. So this is odd. I would not take my time to do this unless you're just fascinated by the process. I would just look at the exponents. If they're even, it's an even function. If they're odd, all of them are odd exponents, then it's an odd function. If you've got a mixture, then it's a neither. It's as simple as that. Okie doke, let's keep moving. Piecewise functions, we're going to do lots of these. We're going to do 2 pages of these. I love these. These are, and again, it's just like so much else that goes on in this class and maybe in life. What happens here is that the first time is a little confusing, the second time is less confusing, and the third time you are on top of it. So let's get you on top of it. Graphing piecewise defined functions. That means we're not going to have a smooth line here. That means we're going to have a break. We're going to have 2 graphs on the same graph. So let's look at how we're going to do it. It says f of x equals, and then 2 rules. We're going to play x squared plus 1 when our x is less than 0. We're going to play a different game, x minus 1, when our x is greater than or equal to 0. So it depends on what the x is, which rule you pick. So let's look. F of negative 1. Okay, which club is negative 1 in? let's see, -1 is less than 0. So I'm going to apply that rule, the first rule, to -1. So I'm going to do f of -1 equals -1 squared plus 1. I'm going to put it into the first one because that's where he belongs. -1 is less than 0, so I'm going to have to do this equation for him, not the second one. He's not bigger than or equal to 0. He's negative, so he's going to be, we're going to abide by this one. So -1 squared is 1, 1 plus 1 is 2. I'm not going to put anything over here yet because these are interesting to get you to learn, but this is not how we're going to put numbers over here. So I want to look at this so we can understand what these rules are about. But when we go to graph, we're going to do something slightly different because that's what we're going to do as we progress. F of 0, let's figure out which rule he belongs to. Well, there are zeros on both of them. But this says x has got to be less than 0 for you to join this club with 0. This is 0. We're going to have to go where x is greater than or equal to 0. Our x is equal to 0. So this is the club that he belongs to. So we're doing x minus 1. So f of 0 is going to be done x minus 1, not x squared plus 1. So we're doing 0 minus 1 and getting a -1 out of that. And then finally, f of 5, you got to decide which club he belongs in. He's not less than 0. He's bigger than 0. So we're going to put 5 in here. F of 5 will give us 5 minus 1, which is 4. So we've got that. Okay, that is interesting and allows you to get a feel for which club he belongs to, which is what we're going to be doing every time. But how I'm going to be doing these once we get started and how you're going to do them as you start doing them, now that you've learned this kind of thing a couple of times, what I'm going to start out with doing is not looking at these three. I'm going to look at the rule. I'm not going to have 3 numbers here. You can see once we get here, they're not giving us some f ofs. We're going to be making this completely on our own. So let's do how we'll do then. What we're going to do is start with where the break is. Where does the club change? It changes at 0. So I'm going to draw a wall here, and I'm putting it to the side so I can see it. But it goes down where x equals 0. I know that what's happening over here on the right-hand side will be different from what's happening over here on the left-hand side because I've got 2 rules. One that takes me to x is less than 0 that describes over here on the left-hand side of my wall, and one that describes what's happening on the right-hand side of my wall. Okay, let's start with the first one. Here's what I would be doing. I would be setting up a t-table for numbers that are less than 0. Well, I'm not supposed to start with 0, but I need to know what's happening right between 0 and 1. So I'm going to include 0 and then the other numbers there, -1 and -2. Those are the whole numbers that go from 0 less than 0. So I'm going to grab 0, but I know he doesn't count because it doesn't say I can include him. So I'm going to write myself a note, open. It's going to be an open circle at whatever happens here at this 0, because this 0 is not part of the first rule. Almost, but not quite. You'll see what I'm doing with this open as we go. Right now, if you've never done piecewise, you're like, what the hell is she even talking about? You'll get it though. You'll get why I'm writing open there, because I'm going to do it 4 more times. So let's see. Let's put our rule in here. X squared plus 1. 0 squared, that's 0, plus 1 gives me a 1. Let's look at the next one. Let's plug in -1. -1 squared gives us 1. 1 plus 1 is 2. And let's put in -2. -2 times -2 gives you 4. 4 plus 1 is 5. So let's plot these. 0, 1, 0 says don't go sideways. 1 says go up 1. Put an open circle there because that's not part of it. 0 is not one of our answers or one of our club members for this club. -1, 2, -1, positive 2 is, and -2, positive 5. So that's half of a parabola, and it looks like that. I know it's a parabola because it's x squared. You might not know that, but you're learning it, and you will learn it a lot in 2.4, 2.5, whenever. So that's this half of the wall. That's the description of the first half. Now let's go look where numbers are greater than or equal to 0. Let me build another t-table. I'm looking at the right-hand side of the wall. 0, 1, and 2. 0 does count. We're going to fill that circle in because in this club, 0 is a member of it. 0 is not a member of the first one, but it is of the second one. Okay, so let's put in our x's. 0 minus 1, 1 minus 1, 2 minus 1. Okay, and I'm going to draw this with a different color. We've got the wall here, and you're going to see it's a really distinct difference. Let's look at 0, negative 1. 0 says don't go sideways. 1 says go, negative 1 says go down 1. And I'm filling that in because 0 gets to be a member of the second side. 1, 0. 1 says go sideways 1. 0 says don't go up. 2, 1. Over 2, up 1. And that's a straight line because there's no x squared involved. That's this map right here. Those are the instructions. This is the picture. This is like your driver's license. It has your name on it, and it has your picture on it. So this is the name of what we've done. This is the picture of what we've done. Okay, let's do that again. If you don't completely get it, pick up something from it, and let's pick up something each time. Okay, I'm going to go ahead and go through these three just so you can see that there's some, hoping you dovetail with something else you know. Okay, let's look. H of x. We have 3 rules here. If you're less than 2, you belong to that club. If you are 2, including 2, all the way up to 4, 2, 2 and a half, 2 3/4, 3, 3 and a half, 3.9999, and 4, you're in this rule. Oh, that's weird. We'll see what that means later. And then the last rule is when x is bigger than 4, you're going to grab this rule. Okay, h of 1, you have to decide which rule of these 3 you're playing with. H of 1 is not between 2 and 4. It is less than 2. So we're plugging a 1 in here. 1 squared is 1. 1 plus 3 is 4. H of 3, which club does 3 fit into? It's between 2 and 4, so that's the rule we're going to use. 7. Couldn't be easier. You're not doing any math. H of 4, now you've got to decide which of these clubs it belongs to. It is 4, so it's not bigger than 4. Don't use this one. It falls between 2 and 4, including 2 and 4, so that's another 7. Okay, that is good information for you to see how this works, but when we go to do this, here's how I'm going to do it. I'm going to look at where my walls are. My walls are at 2 and 4, looking for all of the numbers over here. So I've got a wall here at 2, where x equals 2, and I've got a wall here at 4, where x equals 4. That means I'm going to have something happening to the left of the first wall. We're going to have something happening between the 2 walls, and we're going to have something happening out here on the right-hand side of the wall, of the far wall. So we've got 3 different things to look at. So I'm going to start with where x is less than 2. Okay, I know that 2 doesn't count here, but I want to see what happens as it gets really uptight against this wall. So I'm going to work on 2, but that's going to be an open circle. It doesn't count there. Let's look for other numbers that are less than 2. That would be 1 and 0 here. And you can use numbers that are over here. I'm just going to always go one by one. I want them tight in there to see what happens. Okay, so let's work the left-hand side out. If we put a 2 in here, x squared is 4, 4 plus 3 is 7. Put a 1 in there, 1 squared is 1, 1 plus 3 is 4. Put a 0 in there, 0 squared is 0, plus 3 is 3. Okay. This is a parabola, so it's going to be doing something weird. Let's look at it. Let me grab a black pen for this one. So 2, 7, go over 2 and up 7. Maybe here, don't forget it's an open circle. 1, 4, over 1, up 4. 0, 3. 0 says don't go sideways. 3 says go up 3. Okay, I'm going to include one more to see what's happening with this. I'm going to include -1 because I don't know what's happening over here. Is this, what is this doing? -1 squared, that's 1. 1 plus 3 is 4. So -1, +4. Oh, there, my parabola is turning back around. So what I'm looking at is that, and I know it's going to continue on because it's a parabola. It's got an x squared on it. That looks really VE. It shouldn't be VE. It should be more curvy there, a smoother, softer curve. Okay, so I've discovered what's happening over on the left-hand side of my walls. Let's discover what's happening between the walls. Let's look at, let's see, we start with 2. This is between 2 and 4. So let's look at 2, 3, and 4, and it includes both of them, so there are no open circles here. 2 counts, 4 counts. So if we put a 2 in here, well, there's nothing to do. It's a 7. Put a 3 there, it's still just a 7. Put a 4 in there, it's still just a 7. So let's see what we've got here. Let's graph it over here. 2, 7, go over 2, up 7. I'm going to fill that in. 3, 7, go over 3, up 7. 4, 7. So there, that's what that's looking like. So our piecewise graph has a parabola to begin with, a constant line there, and now let's see what's happening on the right-hand side. So let me build another t-table. The right-hand side belongs to numbers that are bigger than 4. I'm going to start with 4, but I know it needs to be an open circle there because I want to see what happens right up against the wall. 4, 5, and 6 would be good numbers to use there. So put a 4 in. 2 times 4 is 8. 8 minus 1 is 7. Put a 5 in next. 5 times 2 is 10. 10 minus 1 is 9. Put a 6 in next. 6 times 2 is 12. 12 minus 1 is 11. Okay, let's build that guy. 4, 7, we already have that. Over 4, up 7, and it's already filled in. It's good there. 5, 9, go over 5, up 9, maybe there. Go over 6, up 11, maybe there, something like that. Connect the dots, that's a straight line. So there's our piecewise graph made of 3 pieces, 3 different rules. Okay. Next, they're telling you the domain is -infinity to +infinity. That's just to let you know that anything works. You can use any number you want to, and it'll go to infinities. Graph the function and determine the range. I'm going to forget to do that likely, so let's make sure that I remember that. And I know that some of you struggle with that concept of what is the range. Domain we're pretty good at. Range is a little bit weird. Okay. Let's see. 6 times x if x is less than 0, -6x if x is greater than or equal to 0. So let's start by getting our wall built. The only number over here is 0, so my wall is happening here, all the way down. There's my wall. Something's going to happen on the left-hand side that is different from what's happening on the right-hand side. So let's set up, we don't have those annoying f of x's going on. We can set up our own little things. I want to look at what's happening over here. I know that 0 does not belong to the first club, so it's going to be open there. But I do want to see what happens to the east of -1. Okay, so we're looking at x is less than 0, so 0, -1, and -2. Let's look at those numbers. Okay, so I've chosen 3 points over here to look at. Let's plug a 0 in. 6 times 0 is 0. 6 times -1, and 6 times -2. All right, let's see what that's going to look like over here. 0, 0 is open. -1, -6 is right here. And -2, -12 is way down there. So it's doing something like that. And that should be a straight line. Straight line there. Because this is just x to the first power. Nothing fancy there. Okay, let's look at the other half of our graph, the other side of our piecewise function. We're looking at -6x if x is greater than or equal to 0. So we're looking at the right-hand side where x's are 0 and bigger than 0. So I'm going to look at 0, and he'll be filled in because he belongs to this club. And I want to look at 1 and 2. Those are the easiest numbers. -6 times 0 still gives us 0. 1 times -6 gives us -6. And 2 times -6 gives us -12. So 0, 0 filled in. 1, -6 be right here. And 2, -12 would be way down there. So that's looking something like that. And although that sort of looks like he wants to be a parabola, he is not a parabola. There's no x squared in sight. These are two straight lines. Okay, let's find the range now. The range, let's start over. The domain, we've already been told, is everything on the x-axis, and you can see that. That's going to go all the way to -infinity, all the way to +infinity, out that way. Now you've got to turn your brain 90 degrees to look at range. Range is this guy. Range is the thermometer. I'm not using any of the positive numbers on the range, so I know my range is going to stop right there at 0. But where does it start? Where do I start using the thermometer? The y-axis. I can see that these ponytails will go all the way down to -infinity. So I start at -infinity. I stopped using it at 0, and we had a filled in circle there at 0, so we'll use a bracket there. Okay, let's move to the next one. We've got two rules. First thing we need to do is build a wall. Decide where your wall is going to be. I'm hoping you decided at -2. So let me grab this one. There's my wall. Oh, I think walls are so helpful when you start drawing these. Without the wall, I don't have a feel for what I'm looking at. So we have two sides. We have the left-hand side of the wall, and we have the right-hand side. Where x is less than -2, that's over here, and that's what we're going to explore first. So let me build us a little t-table. We're looking at -2 and points to the left. So -2 will be open. -2 is not included here, but it'll take us right up to the wall. -3 and -4 are the next 2 points. You could have picked -6 and -10 if you want. I just think it's easier to stay close. So let's plug these numbers in. -2 plus 3, -3 plus 3, -4 plus 3. Let's go graph those. -2, 1 is right here, but it's an open circle because -2 is not a member of this first club. Then -3, 0 is right there, and -4, -1. That's a line. You know it because there's an x to the first there. It's just to the first power. All right, let's go look at the other part of our function. Let's go look at the right-hand side, on the right-hand side of -2's wall. So if we're looking at those, we want to start with -2, then I'm going to use -1 and 0. If you're just, not a fan of negative numbers, you can skip over here and use 1 and 4 or 1 and 5, anything you want to. I'm just going to go ahead and get us we're using -2, that's the wall, then -1 and 0. Feel free to use any other numbers you want to, so long as they're over on this side of the wall. Okay, -2 minus 3 is -5, -1 minus 3 is -4, and 0 minus 3 is -3. So -2, -5 is right here, and it's filled in. It counts because -2 is a member of the second row. -1, -4, and then 0, -3. So we have those two parallel lines, parallel segments, one to the left of the wall and one to the right of the wall. Okay, let's do this again. Last time to do this on these practices. Okay, first build a wall. Put your wall up. I'm hoping you're putting a wall up at 2. How do you know what that the second line went upward? The second line, let's see, let me first catch who asked me that question, Chloe. You know it because you've got to connect those 3 dots, and the dots can't go this way because you've got a wall there. They can't go past that wall. What happens past that wall is this rule, not the second rule. So it has to start at the wall and go somewhere. Good. Thank you for asking that. I appreciate it. Okay, so let's build ourselves a wall at 2. Nothing's going to go past it on either side. You're going to get to the wall and stop. You're not going to go past the wall. Okay, let's see what we're going to do here. Let's look at this first one. I'm going to start with 2. I'm going to, if you want it, see, we're going to multiply times a half, so we're going to get halves. If you're not a fan of that, then don't use odd numbers. Use 0 and -2. But I want to show you what to do with odd numbers. So we're going to use 1 and 0 for that. That will be 3 numbers that are on the left-hand side of the wall, 3 numbers that are less than 2. Make sure this is open. We're going to put an open circle here because 2 is not actually a member of that club. Okay, half of 2 is 1. 1 plus 1 is 2. Half of 1, half of a pizza is a half of a pizza. So a half plus 1. So we're getting 1 1/2, or if you want to think of it as a decimal, 1.5. And then half of 0 is still 0. 0 plus 1 is 1. Okay, let's see. 2, 2. Over 2, up 2, open circle. And I can't go to the right. My wall, these are for numbers that are less than 2. It has to go this way. So I've got 1, go over 1, go up 1 1/2. So you're right there kind of in no man's land. And then 0 says don't go sideways. 1 says go up 1. This is a line. So it looks something like that. It cannot cross over into this side. It's not allowed there because it only controls numbers that are less than 2. So it's the numbers that are on this side of the wall. Now let's go look at numbers that are on the right-hand side of the wall. 2 and bigger. 2, 3, and 4 will do. -2, negative x, so that's -2 minus 1, so that's a -3. Put in a 3 for x, and you're looking at -3 minus 1, so that's a -4. And put in a 4 for x, and you're looking at -4 minus 1, so we get that set of numbers. See, we've got 2, -3, go over 2, go down 3. That's a filled in circle, just a normal dot because 2 is a member of this club. 3, -4 is right there. And 4, -5 is right there. We're not going to go this way because we can't go past the wall. The wall is a wall. Your line can't go past it. So it's going to be here and beyond. Those are the numbers that are bigger than 2, which is what we're describing. And that's what we've got. Okay, any questions on those before we move on? Oh, range. I did not do range up here. Determine the range. Okay, I told you I was going to forget that. The range, remember that domain we're told is -infinity to +infinity. That's all of that. We don't have to worry about that. They gave us the domain. Let's look at the range. That's using the thermometer. So how far down on the thermometer do we go? Well, look at that one. That goes all the way down to -infinity. So the range is going to start at -infinity. So it comes up here. This one comes up here and he stops. But look, this guy takes over for him. He overlaps him, in fact. So on the thermometer, we're using up all of the negative temperatures, all of these temperatures, and then all of the positives. So it's a full range on that one in addition to a full domain. We were not asked to find range here, but let's do it. Let's do it because this is a weirdo, and weirdos are always good for you to think about. Okay, so remember with domain, we're looking at the x-axis. It didn't tell us anything about the domain, but I can see that we're going all the way to the left. We're going all the way to the right with no gap. So the domain is the negative infinity to positive infinity. Range is not going to be that, though. Let's look at what we've got with range. Let's start at the bottom. Okay, so this guy will take us all the way to negative infinity. So it looks like we're absolutely starting with negative infinity. Let's watch out for that, though. This one stops right here. Does this guy pick it up there? Yes, he does, because he comes down here. So he will pick up the thermometer. Well, actually, he goes all the way down to negative infinity, doesn't he? So he has got this covered. He's got it covered at 0. He's got it covered at 1. Ooh, that's where he stops. The thermometer stops at 2. The highest temperature this drawing gets to is 2. And it does not include 2. We don't get to include 2 on the thermometer. It only goes to 2, almost up to 2, to 1.9999 infinitely, and stops before it gets to 2. And this graph has no coverage up here. Okay. Moving away from graphing, looking at a little bit of algebra. This is going to be weird, and we're only doing it twice, so just follow the algebra. Let me show you what we're going to do here. First thing we need to do is look at this formula. Evaluate a difference quotient. You won't have to memorize this. I'll give this to you on the test. We've got things going on. We've got a fraction. The first thing you've got is f of x plus h. Then you're going to subtract all of f of x. And on the bottom, you're going to write an h. That's what we're going to do twice here for f of x equals negative 5x and a little bit more complicated one. Okay, first it says find f of x plus h. That's the first thing to do. We're going to worry about our mess later, but we need to find this because it goes up here. So let's first go find f of x plus h for this function. So if f of x is negative 5x, we're told that, let's go find f of x plus h. This is why we've been doing this kind of stuff for a couple of days now. Everywhere you see an x over there, you're going to put an x plus h. Oh, there's an x. Let's put an x plus h. What does that give us? Let's distribute. Negative 5x minus 5h. There's our first answer. That is f of x plus h. Okay, so we have found f of x plus h. I'm going to put a check mark there. I'm done with that. Next thing I have to do is go find this mess. So let's find that mess. Let's look. We need f of x plus h minus f of x, all of that over h. Okay, let's get it. I'm going to put an h down there. F of x plus h, we just found that out. That's negative 5x minus 5h. We just found that out. That's why we did this piece to help us here. Then we've got a minus sign, and I'm going to put that in orange. There's orange right there. Then we're going to put f of x. F of x, we know, we've already been told, is negative 5x. Ooh, we've got a minus there. Let's cancel those out. Now let's look at simplifying the numerator. We're going to be able to cancel stuff. That's the game we're playing here. Look, you've got a negative 5x and a positive 5x. Cancel them out. So we end up with negative 5h over h. And you know you can cancel the h's. So you end up in this problem with a negative 5. Poof. Just made that happen. Okay, let's go do the same thing down here with a slightly more messy equation. I'm going to leave this so you can see it. First thing we need to do is find f of x plus h. They're going to give us f of x. So I'm going to copy it. X squared minus 3x plus plus 8. Now I want to first find, my first job in this problem is to substitute in x plus h in place of x. So there's an x. I'm going to put an x plus h. There's an x. I'm going to put an x plus h and then finish it out. X plus h squared, that means x plus h times x plus h, and all of a sudden you got a FOIL problem, so let's FOIL that out. First, x times x is x squared. Outside, that's an xh. Inside, that's another xh. We'll combine them in a minute. And last, that's a plus h squared. These two are like terms. So now I have x squared, I have one of those, I have another one of those. So I have two of those. I don't know what an xh is. Let's say it's a marker. I got one marker and two markers, so I've got two markers. Okay, that x plus h squared is this business. Let's put it down here. Plus 2xh plus h squared. Now I'm going to distribute -3, so I've got -3x minus 3h plus an 8. See if we can combine anything. Got an x squared. I've got an xh. I've got an h squared. I got a plain old x and a plain old h, and I've got a constant. I don't see anything in there I can combine. So this is the answer to our first part, the x plus h, f of x plus h. Now we can go do the difference quotient. We can do this messy thing that we've created here. So I'm going to rewrite it, f of x plus h minus, oh, that wants to, well, that's okay, that's part of the formula, minus f of x over h. That's what I'm going to do. There's an h on bottom. F of x plus h, we just found it out. Let's write all this crap. I'm going to need a bigger boat. Okay, then the next part of the formula says minus. So I'm going to put a minus there. You didn't really see why I put a minus up here. You'll understand why here. F of x comes next. Remember, they gave that to us. It's that guy and that guy and that guy. It's three terms that we're going to have to minus. So you mess this up, you mess the whole thing up. We've got to minus each one of those. So that's in parentheses. We only had one term here for f of x. We only had the one term minus 5x. So that wasn't a big deal. That wasn't a place to trip over. It is a place to trip over here. You're going to have to distribute that. So let me do this. I'm going to rewrite all this first part, h squared minus 3x. Okay, now minus x squared, a negative times a negative 3x gives us a positive 3x, and a negative times 8 gives us a negative 8, all of that over h. And now just go to town here looking for stuff to cancel. You've got an x squared and a negative x squared, gone. You've got a 3x and a negative 3x, they're gone. You've got an 8 and a negative 8, they're gone. So let's collect what's left. 2xh plus h squared minus 3h, and that looks like that's it, all of it over h. As long as everybody's got an h to give, we can cancel out. We've got an h there, there's an h on that term, and an h on that term, and an h on that term. So we can cancel out one h on everybody. So if I get rid of one h here, he's gone, he's gone, he's gone, and I'll have one left there, one h left because there were two to begin with. So this gives me a final answer of 2x plus h minus 3. That's the final answer for the difference quotient. Okay, this will always work out cool. This will always work out nice and neat. So use these as examples. You probably will have one on the test, but I will give you the formula for it. It's just a good algebra exercise. Okay, let's look at our last problem in this section. And it's just a real life problem. Let's see. A telephone company offers a monthly cellular phone plan for $45. That includes 400 free minutes plus 30 cents per minute for additional minutes. So if you never pick up your phone, yeah, that's likely, it'll be $45. If you talk for 1 minute, it'll be $45. If you talk for 100 minutes, it'll be $45. If you talk for 400 minutes, it'll still be $45. But if you talk for 401 minutes, that's when it's going to be $45 plus an additional 30 cents per minute. So here is the function written out for you, c of x, and notice it's a piecewise function here. It's $45 if you speak 0 minutes all the way up to 400 minutes, anywhere in there, and your cost that month is $45. After that, if you talk more than 400 minutes, then it's going to be the fixed cost of $45 plus 30 cents per minute for every minute over 400. Like if you talked 401, it'd be 401 minus 400, so 1 minute at 30 cents. If you talk for 500 minutes, that'd be an additional 100 minutes, 100 times that. And we're going to do this work. Okay, let's do this piecewise, same as we did before. We want a bar at 400. So we're going to play with these being 100s each. So 100, 200, 300, 400. 1, 2, 3, 4. Here's where my wall is going to be in this piecewise function. One thing happens over here if you speak less than 400 minutes. One thing happens over here if you speak more than 400 minutes. Now, something that's significant in this graph is we don't go below 0. So we're not going to have any of this happening. None of this is happening at all for us. Our graph starts at 0 minutes. You can't talk for fewer than 400. You can't talk for fewer than 0 minutes. That's not a thing. Okay, let's look at this function. We're looking at between 0 and 400. So I'll just do 0, 100, 200, 300, and 400. It does include 400 minutes. If you talk for 0 minutes, you get a $45 charge. If you talk for 100 minutes, that's a $45 charge, and on and on and on. So all of those will be 45 minutes. So let's say that these are by tens here. We're doing 0, 10, 20, 30, 40, 50, 60, $70, like that. So let's see. 0 is at 45. Oh, that's not 45. 0 minutes, 0, 45. 0 says don't go sideways. 45 says go up 45. 10, 20, 30, 40, right here. How about that? 145, go out to 100 minutes, up to 45. 200, up to 45. 300, still $45 bill. 400 minutes, still a $45 bill. So that describes when you talk between 0 minutes and 400 minutes. That's the left-hand side of our wall. Now let's see what happens on the right-hand side of our wall. Has to be bigger than 400. I'm going to include 400. That's open. I know that, not including it. Let's look at 500 minutes and 600 minutes. So at 400, if x is greater than 400, it's $45 plus, let's see, let's do this, $45 plus 30 cents times 400 minus 400. 400 minus 400 is 0. 0 times 0.3 goes away, and you're left with 45 minutes, which we already knew. Let's look at 500 minutes. That's $45 plus 30 cents for every minute over 400. 500 minutes is 100 minutes over. 0.3 times 100 is 30. 45 plus 30 gives you $75. Craminy, they think a lot of their plan. They don't think much about you talking. And then 600 is $45 plus 0.3 times 600 minus 400. That's 200. That's going to be $60 extra. 200 times 0.3. 45 plus 60 is 105. Dang. Find another plan. So 445 is right there. It's hollow, but we've already got it filled in from the previous rule. 500 and 750. So there's 750 maybe right there. And then 600 minutes and 105. So man, that thing goes shooting up. It goes up there. I think you're matching on that graph. Okay, let's move forward. Next, where's my white pad? There we go. Next, let's look at the next section. I want to get a couple into this. Let's see. Okay, 2.3. 2.3, we are doing linear functions. That means lines. Linear functions and slope. So we're going to do some reviewing for those of you who are used to doing this. Slope, let's look at that word. Slope is the lean of the line, how it leans. And it's talking about it from left to right. We do a lot of stuff in here from left to right. So that on a graph, let's see, let me grab some of this. This guy right here, that has a positive slope because he leans as you go from left to right. He is going up, so he's a positive slope. This guy right here, as we go from left to right, he has a negative slope. He is falling from left to right, so this would be a negative slope. From left to right, this black line from left to right has a positive slope. He is rising from left to right. So you have to look at it as you read from left to right. It's going up, so it's a positive slope. From left to right, it's falling. That's a negative slope. We'll look at those in just a second. The formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You're going to have to identify that in my math lab, but that's not the way I'm going to teach it. I'm just going to teach you to subtract the y numbers. You don't need those sub 2, sub 1. Those aren't exponents. They're not up above the y. They're down below the y. X sub 2 minus x sub 1. You'll be matching on that. Slope also, you've heard, is rise over run. We will talk about that. So a positive slope, that would be a positive slope. If it rises from left to right, and that's what they'll call it, rises from left to right. A negative slope will look like this. That's a negative slope because it falls from left to right. A slope that equals 0. A slope that equals 0. No effort involved in your climbing at all will look like that. That's a slope of 0. This slope, you have to hoof it. This slope, you're falling. That's a little bit easier. This slope, 0 effort, looks like that. And then a slope that is straight up and down is undefined. And we will not look at a lot of those because those are not functions. Look at that vertical line slope problem. Beep, 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 beep. That's a bad one. But that is called undefined, and you are responsible for it, of course. We have two formulas that we use in building lines. One of them is y equals mx plus b. This is called the slope-intercept form of the line. Slope because m is the slope. Intercept, where does it cross the y-axis? Because b is the intercept. So this line gives us the slope and gives us the intercept right there. When we put numbers there, you'll have the slope looking at you in the face. You'll have the intercept looking at you in the face. Those will both be numbers eventually. So this is called the slope-intercept form because that's what it's got. The other formula you have to worry about is y minus y sub 1 equals x times x sub 1, and that is called point slope form. It is called point slope form because you've got a point, x and y, right there, x sub 1, y sub 1. That's the point. That's supposed to be a y. X sub 1, y sub 1. And then the slope is the m. So if it's got a point and a slope, it's called point slope. If it's just got slope and y-intercept, it's this form. Now, for those of you who love graphing and were comfortable with this in high school or had it in a developmental class, then this is review for you. Some of you, your brain's on fire right now, and I get that. So I'm going to slow down, but this is the stuff in the beginning that you need to know that we'll come back to as we develop stuff. Okay, so let's develop. Let's look at our first problem here. Y equals 2/3 x plus 4. That's a line. If you were going to graph it, they're going to ask you what would be your first step, what would be your second step as you graph it. And I'm going to tell you what those are. The first thing you're going to go is to go back to here and plot 0, 4. So if we were going to graph this, we would start by plotting the y-intercept. That's this B over here. The y-intercept sits at the back, and that's where you're going to begin. See, it is a B, that y-intercept. This is in the form y equals mx plus b form, where we've got something for the m and something for the b. B says begin here. So let's begin at 4. We're going to go up to where 4 is on the y-axis. That's going to be our first step, plot 0, 4. So use the y-intercept. The second step is from this point, the 4, from this point, go up to and over 3, because the slope tells you how to move. That's what the M stands for. It doesn't stand for that, but why not? Up to, rise over run. Remember, the slope stands for rise over run. So we're going to go up to and over 3 from here. So I'm going to go up to, boom, boom, and over 3, something like that. And there's the line. There's his name, y equals 2/3 x plus 4. There's his driver's license picture, his name and his picture, what he looks like. So the first step is to plot where you begin, 0, 4. The second step is from this point, go up to and over 3. So it's always up or down. If it's a negative, it'll be down. Up to, in this case, because it's positive, and over 3. Okay, let's look at some goofy lines. Let's set number 2 problem. Let's look at x equals 4. Here you've got both y and x. That's nice and handy, and this works. This mess of first step is to begin at 4, then move based on the directions here. But when you've only got one variable, let's look at what happens when we do a t-chart. It says x can be 4. Okay, so let's make that point 1, whatever. The next point, oh, it says x has got to be 4. It's obsessed with that. I guess y will be 0. I don't know. Pick your favorite number. Next point, x, oh, it says x has got to be 4. Okay, so let me try -3, whatever. Doesn't matter what's happening over here. This line doesn't care. This line doesn't care what y is. This line only cares. It says, hey, x has got to be 4. Hey, x has got to be 4. Hey, x has got to be 4. Let's look at what that looks like. 4, 1, go over 4 and up 1. 4, 0, go over 4 and stay. 4, -3, go over 4 and go down 3. Connect those dots. That's the line x equals 4. Yes, it's an undefined line, and that's what it looks like. You can't climb that. That's why it's undefined. Its slope is undefined. It is not undefined. Its slope is. Its eyebrows are curly, you know. This is just a feature of it. This is not its name. Its name is x equals 4. Now, the way to find it is go out to x, on the x-axis, go out to 4, and draw a line that is not parallel to the x-axis. Draw it up and down. Okay, let's do one more here. Let's look at y equals -2. That's another line that has only one variable in it, so it's going to be goofy also. Let's look at what we're going to do here. Let's let x be 3 and 0 and -1, whatever. I'm just picking some. I noticed they happen to be the same there. I didn't mean for that. I just picked some numbers. Now, what happens when we plug in x? Well, there is no x. This guy says, hey, y equals -2. When we try to plug in 0, this one says, I don't care about x. Y equals -2. This one says, I don't care where you put that -1. Y needs to equal -2. Let's look at what that looks like. 3, -2, 0, -2, -1, -2. That's that line. That's the line y equals -2. So when you only have one variable, you're going to end up with weird lines. You're going to end up with lines that are parallel or perpendicular to the axes. What you do to find this one is go to where y equals -2. On the y-axis, go find where y is -2, and then draw a line that is perpendicular to the y-axis, that is not parallel to the y-axis. Okay, so we are a little bit, oh, that's perfect. That is exactly where I ended up last semester after the class before we do the review, or class before the class before. Let me grab our sheet really fast and tell you what we're doing. To remind you, if you want your answers to be right on the practice test, put braces there, but you don't have to do that. You won't get any of them right, and I don't care if you get any of them right, but I know some of you, it matters. So don't leave off the braces, otherwise you're going to get a 0. You can practice that as much as you want. You have 2 more days. Today is Wednesday. You owe that to me today, tomorrow, or Friday. If you do not do the practice test, you cannot do the regular test. My emergency is now. My emergency is not going to be your emergency come a week from now when you can't get into your test, or I take off points because you do the scan right. You got to do a practice test for me. Okay, so we have done all of 2.2. We have done a little bit of 2.3, the first 2 problems on 2.3, or the first couple of problems on 2.3. Don't get into 2.3 if you don't feel like it, or get as far as we got with doing the single letter lines, the undefined, those. On Monday, we will finish up 2.3 and do 2.4. They're both fairly short sections. Wednesday, we will review for the test in class. We'll spend our entire day reviewing for this test. It'll be about 25 problems that we'll review. Then you want to go out and do your review at my math lab. Let us do the review in class before you go out and attack that one. When you do go out to do the one at my math lab, pretend like it's a real test. Put your notes away and that kind of stuff. Felicia, I will have the review available. Let's see. This you might need graph paper for, 2.3, yeah. And 2.4 you might need empty graph paper for also. The review I will post on the next week's slide, and you can print that out if you would like to. So, and it'll be 2 pages, I think. Answers are included, but you don't have to print out the review test. The horizontal line. No, thank you for asking that question. The horizontal line's name is y equals -2. That is his name. That is his name. If you want to start talking about what hair color he has, or what eye color he has, or what slope he has, then you can talk about his characteristics. That characteristic is m equals 0, but that is not the name of this line. That is his name. This is the color of his eyebrows. This is this one's name, x equals 4. This is the color of his eyebrows. This is just, the slope is just a characteristic of him. How tall he is, how big he is, that kind of stuff. No, the name is not undefined. That's just what color eyes he has. his name is x equals 4. But if you're asked what is the slope of him, what color eyebrows does he have, then that's his characteristic. But his name is x equals 4. His name is y equals 2. Something I know about him is his slope is equal to 0. Something I know about him is his slope is undefined, but those are not his names. You know, this kind of stuff is on your driver's license, what color eyes you have, how tall you are, that kind of stuff. But those are your names, x equals 4 and y equals -2. Okay, I'm done. I'm going to cut off this. Stick around if you want to